Our unique moat, if there is going to be one, is we want to be the entity which takes open standards and open source and makes it more accessible and production quality for customers to actually lean on and come out with products. We'll do it in many ways, IP, custom, this, that, but that is the one thing which, if we do well, we will stand out from competition. So that's MIPS.
Hi everyone, this is Sally Ward-Foxton with the eTimes. You're listening to our AI podcast, AI with Sally. This episode is sponsored by MIPS. Up to now, chip companies built chips first and developers adapted their software to fit it. MIPS CEO Sameer Wasson believes that model is breaking down. In this episode, we discuss why AI workloads should define the hardware instead of the other way around, and how the combination of MIPS, ARC and GlobalFoundries is reshaping the company's strategy. Sameer also talks about why he believes lowering the barriers to custom silicon could fundamentally change the whole of the industry. Thank you so much to our sponsor MIPS for sponsoring this episode. Here's my conversation with Sameer. Okay, hello Sameer, and welcome back to the show.
Thank you, Sally. Always happy to be here. Appreciate the time.
So I think quite a lot's changed since you and I last spoke. In the last year or so, obviously MIPS has been acquired by GlobalFoundries, and then GlobalFoundries has also acquired ARC, another big IP provider from Synopsys. Can you give us a clue, just set the scene, like how are you positioning the new MIPS?
Yeah, Sally. So first of all, as always, happy to be back talking to you. Positioning on MIPS, honestly, hasn't really changed significantly since we last spoke. I think the probability of our success has significantly gone up, given we are on a platform which allows us to operate at scale. So I think, look, when we last spoke, right? If you remember, we had said, look, MIPS is going to focus on physical AI. I mean, it was a newer concept at that time, and the swim lane we had chosen to try and excel at was how do we make AI and movement and real-time compute, all of it come together. And the opportunity we were seeing was, and still do, was automotive, robotics, a lot of the real-time compute, which is going to come our way as agents start coming to the edge. Obviously, that concept has kind of evolved multiple times over, and it's amplified, and I think people understand it a lot more. We understand it significantly better. And through this journey, I think we've stayed true to the core, which is the potential here is bringing an open architecture, starting to solve with a software user profile first, and then answering that question with an hardware which reflects the processing needs of that user profile. So that stays true. Now, what has happened is, obviously, this is a game of scale. It's a game of capital, and it's a game of reaching our customers where they are. And what we saw as an opportunity was getting on the GF platform allowed us to get all of that. And it's almost to the date, a year since we announced the definitive agreement, and then we closed quickly after. So this year has been, it's been a great journey, because we've integrated into the platform. We still operate as a subsidiary, which allows us to have flexibility on all other quote-unquote foundries as well. We engage deeply with pretty much every other foundry on the planet. Our customers are super excited that we are now on a much stronger financial footing. We have access to capital, we have access to the reach. And honestly, like we've been saying, we've been able to bring RISC-V out of its academic realm into truly operating at scale. And then just staying with the same theme, when we saw the opportunity of combining the ARC team and the ARC portfolio, we jumped at it, because it ticked off exactly all the same things which were strategically aligned with where we were going, which was ARC is known for its real-time compute and low-power compute. ARC serves the same markets, such as automotive and robotics, which we were very keen on. And what was lacking in the pre-ARC MIPS GF scenario was the portfolio. I mean, we were still building the portfolio, and getting it inorganically sort of gives our customers a step function improvement. So we have gone from selling 4 cores to almost 41 cores. We've gone from building an AI accelerator to now still building that, but now we have a team which is almost 200, 250 AI engineers, which in this market is very difficult to grow in the time frame we're talking about organically. So the Yark acquisition was an acceleration of an existing direction. It's been quite an interesting 18 months, right? We've accelerated what we were doing at MIPS by becoming part of GF, and then we've doubled down by going ahead and bringing on the Arc team as well. So no, super exciting.
Can you tell us whether there is much overlap between the ARC portfolio and your IP portfolio? I mean, you both have CPUs, you both have NPUs. Where's the overlap, and how are you positioning them against each other?
Yeah, so it's not we're not positioning them against as much as when we looked at the Arc portfolio, we saw the Arc team was ahead in some of the things which we were about to go start building. So some of it was just pure acceleration of roadmap. We saw the Arc team had already built an AI business based on the NPX accelerator, which I would say outside of obviously the most renowned ones, which are like the top 2 or 3, probably has the largest footprint of customers. It is shipping in automotive, it is shipping in consumer digital cameras. So it's shipping in a bunch of markets which are going to be very, very fundamental to how physical AI happens. So we saw Arc had already done that. And like I said, we saw a talent base which we could absolutely go grow. Now, when it came to the overlap to your question, right? MIPS was focusing on multi-threaded CPUs. We were serving a large automotive customer, Mobileye, which is public. We were serving a very large hyperscaler customer on their DPU and data movement need. And we were starting to go deliver products into the real-time MCU space. Arc complements our portfolio very nicely with higher single thread performance. So we got for workloads which need higher single thread and don't really care about the multi-threading part. We got a portfolio on that. Arc served our needs on the entry-level MCUs very well. So slightly lower than where we were going. So it complemented our portfolio very nicely rather than competed with it. And then now that the teams are together, we're looking at the roadmap as one holistic roadmap. There is no Arc, there's no MIPS roadmap. It's one integrated roadmap. The fact that both of us were already RISC-V, Arc-V, and then MIPS, we don't call it MIPS-V, but MIPS was already RISC-V. The software compatibility and the tools were very common. We intend to continue leaning on Metaware MX as our AI toolchain, and we are going to make that more and more RISC-V friendly. In general, we are leaning very hard towards going completely RISC-V in how we talk about AI as well. And I think that's the story we're starting to kind of write together.
Yeah, that makes perfect sense. For MIPS plus ARC plus GlobalFoundries, it sounds like you want to make this end-to-end platform so that people can build custom silicon. Tell us about why it's better to have all of this under one roof, really, versus just being part of an ecosystem that might offer more choice, for example.
So I think we can do both, right? Look, RISC-V will fail if it doesn't nurture an ecosystem, right? And what is an ecosystem? Let's double click on that for a second. Ecosystem is a group of companies, people, entities, smart people getting together on one common platform and doing their bit so that whoever is the customer of that platform doesn't have to go spend R&D on things which are common and can be extracted while focusing on what they innovate. So ecosystem is about accelerating customer innovation. That's how I look at it. So when I look at the same paradigm, if we can go lower the barrier of customer adoption, accelerate customer innovation, and that lovely phrase we all like, time to market, I think it's a worthwhile investment to make. And if we stay in the RISC-V academic realm, then yeah, ecosystem is happening. It'll happen over 100 years. And it'll take its own sweet time. That's not the way to do ecosystem in my mind. Even if you look at the largest IP provider out there, we all know how much they invested their own capital in nurturing that ecosystem. And it's paying dividends today, right? I think RISC-V has to be very similar. Yes, it's an open standard, so not one person doesn't have to invest all of it. But if we don't start kind of bringing this ecosystem together with capital, with investment, with focus, with direction, with people, it's just not going to happen by itself. The barrier of entries are too high. It'll stay in the academic conceptual realm too long. So what we have decided at GF and MIPS is that it's on to us along with others as well. It's not an exclusive play, but it is definitely us playing our role, where we're trying to bring all interested parties to go create a platform which takes innovation to the next step. Today, I feel it's too narrow. It's like a few people are building all of the AI needs on the planet, and I fully respect what they're doing. It's fabulous to see. But I think with AI being so mainstream for all of us, I think this needs to be broadened, and it cannot be broadened on a proprietary architecture. It needs to be broadened on a architecture where everyone gets protected and everyone gets to innovate. And that's the fine balance we're trying to build. And if it means we are going to spend our capital bringing it together, I think that's our job. So no, I think um, bringing all of it under one roof accelerates that. It's a way of deploying capital to that ecosystem, and we welcome everyone else who's building silicon as well. Right? It's not proprietary. It's not something that I want to build every custom silicon known to man in physical AI using RISC-V or using MIPS. We have a bunch of custom silicon customers who are licensing our IP, and we're making that completely available. So no, I think it's this is a play to go accelerate the ecosystem by putting capital, so that we can get past the academic realm.
To be clear, if someone wanted to license MIPS or ARC IP, but they already work with another foundry, you still work with all other foundries in the ecosystem. I mean, maybe they have a different process node in mind or something.
Yeah, I mean, see, GF is a great foundry on the nodes it focuses on, which tends to be the lagging edge nodes. Most of our business today is leading edge node, and we are obviously working with every foundry who's working that. Our reference platforms on the custom silicon side are focused on GF today because that's the nature of the product we are referencing on today. But as we go forward, you will see some announcements over the next 12 months where we are starting to announce some reference platforms on non-GF nodes as well. So no, I think if you think about GF, there is a foundry business. It is going to do its thing. MIPS is MIPS. MIPS is going to do its thing. We are on the GF platform so that we have the scale, but we are not putting any restrictions on the.
I think there's a lot of companies out there talking about how they have a platform. What's the difference between actually having an integrated partners and actually having a platform rather than just owning more layers of the stack?
What is a platform, right? A platform is something which again accelerates customers' innovation, time to market, blah blah blah. Right. So how do we consider a platform? It's not PowerPoint.
Yep.
Okay. So first and foremost,
it's not only PowerPoint. Yeah.
It's not only PowerPoint.
Yep.
It's about. I mean, what are we doing, right? I mean, it's pretty straightforward. When we say we're going to build an AI platform, what are we building? We're taking MIPS and now ARC IP, putting that on actual silicon, production quality, production intent silicon. We're building the base layers of the software. We are building the tool chain for that AI accelerator. We're building the open source stack. We're putting the chip on a module with standard industry interfaces, and we're making that available. Now, once that is available, a customer can come and intersect at any level of that platform. Customer could say, you know what, you've proven out the IP. I want this IP. I'm going to put it in my SoC or whatever I'm going to do. Customer can come and say, you know what, I like that that silicon part. Can you go modify that for me? And it is my custom ASIC. Sure. Some customers could come in and say, you know what, I love the module itself. I'm going to go take that as a starting point. We can make that available. So I think this is not anything other than saying we are going to go build this product out. The only thing which we are not building, Sally, production intent or production quality, is the application stack. Like we're not building a perception stack, for example. I think we're not doing that. I don't see us going into that realm because that becomes too custom to the application. But any aspect which we feel is a good starting point or is common, we want to go lower the barrier of that adoption. And if we are able to do that over the next year, 2 years, you will see a lot of platforms on reference silicon coming out of the shop. And it'll range from some very small stuff to some very meaty AI accelerators as well.
MIPS and ARC, of course, are kind of at the same level of the stack. I'm curious about how you're going to work together kind of day to day. You mentioned, ARC has strong software expertise, for example. Like, how are you going to work together just at least to start with?
Yeah. No, look, MIPS was still forming that expertise. But one of the reasons why we moved so quickly on the acquisition was that I didn't want to go do what we just did after spending a year and a half of building the same stuff, like you said, right? If we had not acquired ARC, we would have just continued down our roadmap and essentially build what ARC already had. So if there was a time to do the acquisition, it was right then and there. After that, it just becomes like you have more and more of overlap versus this. So no, I mean, honestly, we don't at MIPS, we had plans of building a tool chain, blah, 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 but we were just starting that journey. We just acquired Metaware MX and we're going to kind of integrate it in a way where it is not only NPX, it will also support the S8200, but we are going to take that forward. So when a customer sees it under the same tool chain, they will have optionality of what accelerator they're trying to go service. But the direction, the big change in direction is no proprietary AI accelerators. We are going to go 100% RISC-V AI accelerators and continue going down that path on a tool chain which is well known. So the customer software compatibility part comes in very, very well. Because they're using the same tool chain. There is work underneath the tool chain, as you can imagine, but we want to make sure that transition is very smooth.
I think one thing you want to do is allow customers to let workload define the hardware, which kind of means flipping the hardware and starting with software. What does that look like in real life? Does it change who in the company is working on the hardware, for example?
Yeah, I mean, vibrant discussion on that, as you can imagine, right? It's how we want to approach the problem. See, honestly, the problem on the CPU side is magnitudes easier than when you start bringing AI on.
Yeah.
Because, CPUs also, I mean, different workloads, but end of the day, the software sort of is known use cases. They're more and more coming in with agentic coming in, but CPUs is there. It's still well formed in what people are looking for. And software engineers on CPU are like, I know what I'm expecting. I need to have this much. Give me that. Okay. That's at least what we have experienced over the past 18 months of putting Atlas Explorer out. You start taking that same discussion with AI engineers, and even internal AI engineers are consuming that tool more than our CPU engineers. Why? Because it truly is the wild. Like what post transformer model runs at what performance. It's a curiosity which people are only able to answer today after they have the hardware. And if we can continue making that gap better, where you bring that development cycle ahead, we are going to start solving the software engineer's biggest dilemma. I mean, in any company we work with, any of our customers, I throw out a number, 5:1 ratio of hardware to software, maybe more. So it's the 5x number of resources we want to go engage and get busy on building the AI rather than waiting for the 1x to go deliver a piece of hardware. Hardware is important. Without hardware, nothing happens. But I think it's about bringing both of them together on that development journey so that we're not wasting time and we're building a solution which actually meets the needs. Honestly, most physical AI workloads are not known. I mean, I'll be one of the first ones to say, I wish I could tell you exactly what the workloads out there are going to be. I think physical AI is going to test the boundaries of electrical engineers and computer engineers talking to engineers of other backgrounds. And just the language is different, right? And I think translating that cannot be, you go to a material scientist or you go to a physicist and say, I have these many tops. They'll be like, okay, good luck. Now what do I do? I mean, just forget that. Even take a simpler example. I want to do perception for a drone running at this speed. Biggest question is, how many tops do you need? I don't know.
Yeah.
Let's start putting in. So I think those basic stuff, right? I think we can answer those questions more elegantly if we provide customers that bridge with a tool.
Yeah. I guess from the outside, to me, it looks like hardware design takes ages, takes years, and it's less adaptable as you kind of go through the design cycle. Software can change relatively quickly. Workloads, as you're saying, can change all the time. Nobody knows what workloads are going to look like. How do you avoid getting stuck in a loop where you repeatedly change the workload and then have to change the hardware to match?
Well, you can't, right? I mean, so you have to dimension for what you're taking to production. But then the world's getting to a point where the cost of every tape out seems to be going up, but the cost of actually doing a derivative chip is actually coming down.
Oh, yeah?
Because Sally, you're using so much more AI in our development today. I mean, 5 years back, a microcontroller would cost us to build $25-30 million. Today, it's less than half of that. Why? Because a lot of it is becoming standard. We are quoting some of our customers. If they're coming on the platform, it's single-digit $1 million to go build a custom MCU, right? So we have to go challenge that cost paradigm, that thinking of saying that doing hardware is difficult. Now, all hardware is not the same. If you're building one of those large AI accelerators, I think you can't have a cadence of whatever faster than once in 18 months or whatever these guys are trying to go achieve. But if you're doing a lot of simple AI and microcontrollers and sensors, I would argue you can build a platform which you have a faster cadence. Then you start thinking about how you want to intelligently use chiplets and even improve product throughput further for different use cases. I think there's enough there where by leveraging AI, by leveraging open standards and open IP and open tool chains, you can start challenging this entire paradigm of saying hardware development is slow and expensive. And the best way to do that is to make it software informed. You make it software informed, you make it more accessible, you make it more iterative, and you're able to come out and do that. So I think, honestly, if we are successful in what we're doing in MIPS, just across, we will have more people building hardware, more software aware hardware, and coming out with more products rather than having to go shove the existing product down someone's throat because it moves too slowly. I don't believe that anymore.
Yeah. Well, that makes perfect sense. Okay, so for the new MIPS GF ARC combo, who do you actually compete with? Who does MIPS compete with and not compete with? And what are your competitive advantages as part of this combination?
Yeah, who do we compete with? Right? It's a fascinating question because it's a unique combo, like you said, right? I mean, there is no one trying to do what we're trying to do like we're trying to do. There are obviously competitors across the spectrum doing everything. They're cutting the same slice differently, right? So if we're competing with, so we got to go normalize it on the customer. What choices does the customer have? And are we one of the choices, and who are we competing with? And depending on what the customer is trying to do, right? When they're trying to go pick a processing solution with IP, we're competing with the well-known. All right. I mean, obviously, ARM is still de facto standard in our market. Becoming less of a standard, people are now, I don't show up compared to where I was 3 years back trying to educate people about RISC-V. I think that's a huge change, right? Now we're showing up to conversations saying, okay, you've educated us. Can you meet our demand? Can you get to this performance? Can you get to this maturity? Can you get to this completion? And there are aspects of the portfolio where we are. There are aspects of the portfolio where we're still developing. And that discussion has now gone from curiosity to signatures. I mean, our licensing quarter over quarter, we're more than doubling number of licenses today. So we are starting to see signatures. So that's good. Soon you should start seeing portfolio level signatures and engagements rather than a socket here or socket there. So that trend is definitely changing. And each of our so in that realm, we obviously compete with other RISC-V vendors as well. I don't think so. There is any RISC-V vendor today who shows up with the breadth of portfolio and the breadth of customer engagements we do. So because of the ARC acquisition and MIPS combination and how we are running our shop, we've sort of gone after the broad segment of auto, IoT, robotics, AI infrastructure, consumer. There are some who are very focused on specific aspects of, hey, we're going to do data center compute, or we're going to do very high performance, and we don't have anything below that quite this. So I think our strategies are different. So we don't necessarily run into a lot of other risk five every day from a portfolio perspective. Our competition is with ARM on the IP side. On the AI side, honestly, we are the entrant, if I think of it, right? I mean, so me saying I compete with the big guys is probably ahead of its time. We got to go build the solution out and bring people on the platform, show them the value of the open platform, open standard, how the total cost of ownership comes down. And I consider what we are doing uh, having the potential to actually be a significant market share on physical AI, partly because if we can go deliver what we're trying to deliver on an open standard and still give customers the performance they're looking for, which I think we can, I think this can be a game changer. So let's see how that evolves. It's still early days on that for us. We have products coming out now, starting to. We got to go prove that out. So that's on the AI side. On the custom silicon side, again, we are entrants, right? We are taking a very different tack on custom silicon than we have seen the Broadcoms and the Marvels and everyone else do. They're building very large SoCs custom for a segment of the market. We are going the exact opposite realm. We're saying we're going to go build components which are AI informed, and bring the cost of those catalog components as custom down. And we're trying to go feed the need, not necessarily on the classic captive guys only, but tier ones, OEMs who have the desire of saying, you know what, my SDV is no longer something which I don't want to differentiate on. If an auto OEM wants to go differentiate on their architecture, there are aspects of controllers which are going to be custom. They have their own IP they want to bring in, and doesn't mean they stop working with the large semiconductor houses. They absolutely do. But for a few devices, they want to go do something different. That's why their car will be different than someone else's car. And that's the demand we're trying to go cater for. And that's only increasing. So the play on custom is if we can bring the cost of doing custom down, let the AI workload drive the need for customization, then we're feeding an appetite which is starting to grow. So again, early, it's I don't think we compete with many on that, honestly.
Yeah.
Because it's a unique business model we're testing. So far, it's starting to materialize, but we don't compete with many with that approach today.
So with the unique business model like what you have, you mentioned a bunch of different market segments for physical AI. They're quite diverse segments, actually: automotive, consumer, IoT. These are relatively diverse. Tell us about who is the typical customer for MIPS as it is today, or what kind of companies are you working with that want to build custom silicon today, or that for them it's within reach, right?
Yeah, I think a lot of tier ones, a lot of auto OEMs, a lot of A&D OEMs, a lot of captive silicon providers like the hyperscalers. I think people who have unique workloads, Sally. And this is not to say that they're all moving away from catalog silicon. Catalog silicon is here to stay and grow and do all the things catalog does. But as physical AI starts coming into the realm of discussion, as semiconductor regionalization starts becoming more and more important, as some tier ones are starting to question what is the true value chain here, because OEMs want to do more, so they have to shift how they play in that. There are very many different desires in the market, which our play seems to be feeding. But end of the day, where we will see success is where our product differentiates, because one is business model. You can cater to that, but end of the day, what we're putting out should be able to solve the problem better than other solutions. So, for example, if we are talking a millimeter wave radar sensor, we should be able to build a radar which senses better and is lower cost than what's available on that. And if you're able to go continuously keep doing that, I think that's the realm you're going to open up. So this is not about replacing all catalog demand with custom. I don't think so. That's practical. This is about what is the next wave of custom silicon which will happen? Because business model, AI coming in, user workloads, cost comes into play in these components. So it's a very ASSP approach, application specific approach, where there's certain applications which an OEM wants to go do something unique. And the only way they can do that is through custom silicon. Earlier, it used to be, oh, I have to sign a $100 million deal, but my volume may be too disparate. Today, we brought that $100 million down magnitudes, depending on the problem statement. So it's a lot more accessible. Honestly, that's the power of RISC-V, right? We've taken that entire licensing paradigm of expensive licenses, black magic, big contracts. We've sort of brought that barrier so low. We're like, here you go. And we take the responsibility of delivering you functioning silicon with GF quality and reliability and warranty behind it. Off you go.
Perfect. I think even since we spoke, which probably was a year ago now, MIPS has grown an awful lot. Can you give us an idea of your headcount? How many people have joined MIPS recently, and which bits of MIPS are you expanding the fastest?
So, Sally, I like to talk about MIPS revenue before I talk
Okay.
about headcount. It's just how I'm trained. So let's see, right? So we went out, and this is public realm, so I can share, right? So we went out like 6 months back, and we announced to the street that MIPS alone, just MIPS, would range between $60 to $100 million on revenue this year. We are well on track for that. We're converging towards the upper end of that spectrum. Half year done, half year to go, but the bookings pipeline is looking good. We have a lot of execution ahead of us, and the revenue is going to be a function of how well can we get product throughput out. So I think so that's converging. Arc has now come on board, and I think Synopsys announced that they are deducting about $40 million of revenue for the year, remainder of the year for that, and that's in line. So you can say MIPS plus Arc should range between whatever midpoint of 80 plus 40. So in that range is where we'll be for this year. Next year is shaping up well. Visibility tells us, based on the bookings we are seeing, that we should have a strong growth year next year as well. And we'll talk about specifics as we get closer to that. We've also stated to the street that our ambition is to go build the MIPS business into a $1 billion run rate by 2030. And the $1 billion run rate is basically anchored on silicon ramp in 28, 29, 2030 timeframe. IP alone doesn't get us there. I wish it could. I wish royalties would ramp that quickly, but they generally don't. So it's a combination of what we're doing on the AI side. It's a combination of what we're doing on the software side. Combination of what I think custom silicon and IP will do. IP is still going to be a pretty big portion of that ramp. So ambition is clear for us: $1 billion business by 2030. This year we should be north of 3 digits as we complete out the year, and let the execution continue. Now, to go feed these ambitions, headcount is important, and quality of talent is more important than quantity of talent all the time, but both matter. So one of the biggest benefits of getting Arc was the global footprint. We now have a very, very strong footprint in Europe, and we're expanding on that Europe. So I think outside of ARM, we may most likely be the largest IP developer in Europe, is my guess. And we take that opportunity to even become broader and stronger there by doing certain parts of our portfolio 100% in Europe, so that we can actually cater to the European sovereign A&D needs and that. So I think that's a very key portion of our strategy. We have development footprints in the US, Santa Clara, Austin, Dallas. India is becoming much stronger. We have some development footprint which we are developing in Taiwan and in China as well. So I think the global footprint becomes pretty fundamental to how we cater to the global customer base. And being part of GlobalFoundries, that's one of the biggest advantages. We have fabs in Malta, in Dresden, and in Singapore. So now we can actually go cater to semiconductor companies, building solutions for those regions as well. So no, I think headcount wise, we're much bigger than where we were.
Yeah, sounds like you're going to need it. Okay, what's on your roadmap, Sameer? You spoke about combining with Arc on software a little bit earlier, but to what extent are you actually going to combine the hardware and software of both
Yeah.
roadmaps? Is it going to become one coherent roadmap, and how difficult is that going to be to do?
No, Sal, it is definitely one cohesive roadmap.
Okay.
Like there is no, like I like to say internally, I'll say the same thing externally. We are not going to drop any customer commit. We are not disappointing any customers in terms of bringing it together. But all our R&D dollars are going to be focused on building one roadmap. So it's the shift in my mind is super clear. All existing commitments will complete and be delivered. Anything roadmap is going to be one. What does that roadmap look like? The foundation is open RISC-V. We are going to go double down. We just became board members of RISC-V. We are starting to go immerse ourselves in various technical committees on that so that we can accelerate the standardization. We are in, and we are going to execute on that. In terms of the products, on the other side, standards are good. What does the products look like? We're going to break the barrier of performance, and this is a perceived barrier that MIPS and ARC are low performance, while some other entities are high performance. I think from a CPU perspective, you're going to see some stuff come out which takes the performance to the next realm, just pure spec-end performance. We will build the highest spec-end multi-threaded core on the planet in the RISC realm. I don't want to go compete with what x86 has out there, but we are going to start building that. We're also going to start presenting that core more than a CPU, just a core. I think it is um, to accelerate that adoption. What can we do from a subsystem perspective? What can we do from a reference silicon perspective? What can we do from a basic software ecosystem perspective? So you're going to see that shift from coming out with very interesting cores and technologies and this to, okay, here's a product and is a starting point for you to start taking. Obviously, we're learning from the best in this industry. You've seen ARM do some really, really interesting stuff to lower that barrier. We may not go all the way and start building custom silicon like that, but I think we will. We are going to get very because trying to retrain customers takes a long time. They're used to something, give them a better solution in the same sort of envelope which they're used to. So that's one. You're going to see some stuff coming out on the AI side, which is like I said, building on our IP, reference silicon, and on AI side, I'm keen on even lowering the barrier by giving a card. Um, and that's being cooked, and more details to come on that. Um, I can't tell you where the next Chat GPT moment will happen, but the probability of it happening on our hardware increases significantly if there is a card out there. That's how I think of it. Um, so
Okay.
so 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 we want to go put that out. You're going to see more complete Atlas Explorer and ASIP, where we are not only catering to the software engineers, we are also giving a lifecycle management tool with complete virtualization of the hardware, which we're coming out with. So that's going to be interesting. And last but not the least, you're going to see us start talking about our ASSP portfolio a bit more, like what are the applications we are going after, um, and why working with us is beneficial. We haven't been very public about it in terms of what are the specifics. Is that's custom, and people always tend to confuse custom silicon with design services, and especially because
Yeah.
we are part of a foundry, they're like, oh, this is design services. It's not, right? We are
No.
actually building ASSP platforms, which are AI informed, and we want customers starting to get active on that. So no, I think 3 years of building, acquiring organically, there's that. Next 12 months is about coming out with products.
Absolutely. I think when we spoke, not last year, but 2 years ago, I think you had not that long been the CEO of MIPS, and you said at the time, I'll always remember this, you're determined to keep the MIPSiness in MIPS. There's obviously been a lot of changes,
Hasn't
acquisitions,
changed.
combining roadmaps. Like, how are you going to make sure MIPS keeps its MIPSiness going forward?
Yeah. No, Sally, so MIPSiness is definitely going to stay, right? There is architectural MIPSiness. Multi-threading is probably what MIPS is always going to be known for, that will stay. Our customers are asking for it. If anything, in the AI world, Sally, there are more applications coming with multi-threaded needs than they were like maybe 4 years back, 3 years back. So I think that has helped us. We're going to persist with that. Now, if you look at the ARC people, in some ways, they're not very different than the MIPS ENS also, right? It's about real-time compute. It's about making sure energy efficiency is core to it. So it's not like we're changing that paradigm. MIPS ENS has grown, I'll say. It has grown to now add more RISC-V, more open. I think this open ecosystem, open standards, open source is very fundamental to how we've evolved MIPS ENS. Our unique moat, if there is going to be one, is we want to be the entity which takes open standards and open source and makes it more accessible and production quality for customers to actually lean on and come out with products. We'll do it in many ways, IP, custom, this, that, but that is the one thing which, if we do well, we will stand out from competition. So that's MIPS ENS.
So MIPS will still be MIPS?
Absolutely. Not changing that.
Perfect place to finish, Sameer. Thank you so much.
Thank you, Sally. This is always a pleasure. I appreciate the time.
Thank you so much, Sameer, for the conversation. And thank you, MIPS, for sponsoring us. If you want to learn more about MIPS, you can go to the podcast page at eetimes.com. Thank you so much for listening.